Haloalkane.
Yes, hello.
Okay. Solution is done.
Yes, solutions finished.
Solution is done. Okay, fine. So I think I have to teach you solution chapter completely. Okay.
Yes.
Acha, one more thing. School se kuch aaya solution you're done in school, na? So what do you think? You know these terms? Henry's law,
Yes.
Raoult's law,
Yes.
relative lowering of vapor pressure, azeotropes, elevation in boiling point. You know these terms?
Yes.
Acha, okay, fine. You know these terms, then what we will do, we will take doubts from you, okay? We will have questions, right? Then you will solve them. And if you can't solve them, then I will explain it, okay?
Okay.
So kind of revision will be there. And if you need a complete theory class also, then also you have to just let me know. Or if I feel while doing those problems that you need the theory classes, then you can take extra class, okay? But in extra class, you have to come, okay? Before.
Okay.
Is that clear?
Yes.
अभी बताइए, where are you from or where do you live right now? Where are you at right now?
Right now I live in Saudi.
Saudi where?
Kobe.
Okay. And which school do you go to?
IISD, Indian school.
Dammam.
Yes.
Okay. It must be far, right? Or is it near?
It's 10-minute drive.
Acha, it's 10 minutes only for you. Okay.
Yeah.
But there are some students who live very far away from Dammam. Okay. Fine,
Yeah.
fine, fine. So today we are going to do osmotic pressure. So we were dealing with colligative properties. Colligative properties. Okay. In colligative properties, we have done with relative lowering of vapor pressure, RLVP. We are also done with elevation in boiling point. And the last class we did depression in freezing point. Today we are going to do the fourth one, that is osmotic pressure. Into osmotic pressure. Okay. So let us see osmotic pressure. Now, before osmotic pressure, you have to understand the idea about relative lowering of vapor pressure. The relative lowering of vapor pressure, it just is that. Suppose you have a solution like this, right? And this has only water. Okay. And then you have a similar solution. A similar solution is there, but here you have water plus salt. Here you have water plus salt. Okay. Now, if you have just water, that means you have only liquid. Yes or no? Correct?
Yes.
Now, yes, Zaid, Hanifa, is that right?
Yes, sir.
Okay. Now, in water and solid, that means we have liquid and solid also. Liquid and solid also. Okay. Now you tell me, liquid has a tendency to get evaporated, right? It can vaporize.
Yes.
But here we have liquid as well as solid, and this solid cannot vaporize, right? It cannot vaporize. Now, if it cannot vaporize, that means it will not escape the solution. It will not escape the solution, and it will not be forming any vapors. It will not be forming any vapors. Okay. And that also what will happen, it will occupy some space on the surface like this. So this is my salt. Let us say that this is red salt. So it is occupying some surfaces. But if I look at only water, in only water, we have just the water molecule on the surface, right? And here we have some salt molecules on the surface also. Now what happens if there are no water molecules, if there are less water molecules in the surface, what will happen? Less number of vapors will be formed, and leading to lowering of vapor pressure. Is that right? Yes or no? Understood,
Yes.
all of you? Okay. Rifat, what about you?
Yes.
Because this is the core of all the all the colligative properties, because even if you read the relative lowering of vapor pressure, उसमें तो ये है ही, नाम नहीं. Then you have elevation in boiling point, freezing, depression in freezing point. Both of these are related to relative lowering of vapor pressure, and similarly osmotic pressure is also related to the same thing. Now in osmotic pressure, I will start this explanation with let us have two containers like this. Okay, let us have two containers like this. And what we will do, we will separate it like this. Let us say that there is some kind of channel here. Okay, there is some kind of channel, and here we have a semi-permeable membrane. Semi-permeable membrane. Okay, we have a semi-permeable membrane. What will happen in semi-permeable membrane? Okay, this is semi-permeable. SPM. Okay, semi-permeable membrane. And then we have two different types of. Okay, here we have only, let us say here we have only solvent, and here we have solution. Here we have solvent, and here we have solution. Okay, and there will be a vapor pressure. Correct, vapor pressure of solvent, right? And there will be a vapor pressure of solution. Okay, and we know the vapor pressure of solution will be lowered, yes or no? Right?
Yes.
Refer Thanifan and vapor pressure of solvent will be larger. So what we will see? Okay, fine. Vapor pressure of solvent is greater than vapor pressure of solution. Okay. Now, the magnitude by which the vapor pressure of solvent is greater. There will be some pressure that will be more in solvent when I compare this with solution. So, in order to make both of them equal, where will I add pressure? Will I add pressure here, or will I add pressure here in A or B?
Sir,
if
A.
I want to make, if I want to make solution and solvent equal, Hanifa, Rifat, what do you think?
A.
A, na? So we will apply some pressure A. Okay, we will apply some pressure A in order to make it equal. And that pressure, it is known as what? That pressure is known as the osmotic pressure. This pi here, that is the osmotic pressure. Is that clear, yes or no?
Yes, sir.
All of you, Rifat, tell me.
Yes, sir.
Hanifa, what about you? Yeah, Hanifa is not here, or what? Hanifa, please turn the mic on. Okay, Hanifa is having some difficulty. I can't hear you, by the way, Hanifa.
I can hear you.
Now I can hear you. You got this all thing, yes or no?
Yes, sir.
Yes? Okay. Achha. Now see, we have already seen that. At this part, this vapor pressure is more, right? Correct?
Yes.
Vapor pressure is more. That means there will be some pressure applied here. Which will be greater than this area, this is A and this is B. So in the A compartment, we have some pressure. In the B compartment, we have a pressure which is a bit higher than that of A compartment. So there will be a pressure here. Now, when the pressures are unequal, what will happen? There will be a flow from here to here. From B compartment to A compartment. Okay, now what will flow from here to here, from B to A? Solvent. Here we have only solvent, hai na? So what will happen? Solvent will move on to this side. When solvent move to this side, what will happen? The amount of solvent will increase. And if the amount of solvent will increase, what will happen? More number of vapors will be formed, and the vapor pressure will also increase, and it will keep on increasing until and unless the vapor pressure of solution becomes equal to the vapor pressure of solvent. Is that clear?
Yes.
Yes.
Okay. This process, it is known as osmosis. So you must have heard about osmosis before. Now, how this osmosis happens? So we'll write the topic as osmotic pressure and osmosis. Okay, right? Osmotic. Let us write osmosis first. Osmosis and osmotic pressure. Okay. So what is osmosis? Please write with me the process of flow of solvent. The process of flow of solvent molecules from a solution of lower concentration, है ना? Lower concentration of what? Lower concentration of solute. Lower concentration of solute to a higher concentration. Sorry, to a solution of higher concentration. Right? To a solution of, cut this, okay? To a solution of higher concentration. Okay. Now this flow, it happens through a semi-permeable membrane. Huh? That we will add here through semi-permeable membrane is known as osmotic pressure. It is known as osmotic pressure. Sorry. I should have written osmosis. No? Okay, we will write about osmotic pressure. Let me know when you're done. I think everyone is done. So for osmotic pressure, you will write two definitions. First of all, the hydrostatic pressure which develops on account of osmosis is called osmotic pressure. Okay, and the other one is the pressure which just stops the flow of solvent is called osmotic pressure. It's called osmotic pressure. Okay, so this definition of osmosis, it is very important. It has been asked in CBSE examination many times. I think it has been asked like almost in alternate years. I think 2011, 13, and I don't know whether 15 के बाद हमको नहीं याद है. But these are the dates in which it has been asked. Okay, 11, 13, and 14. So please remember this definition of osmosis. Please remember the definition of osmosis. It was asked for 1 marks only, but है ना, एक line का definition, it will be asked for 1 marks only. Is this clear? Yes or no? Please tell me.
Yes.
Okay. Now let us see. Now what we have done till now, we have done the qualitative analysis of osmotic pressure. है ना? We saw what is osmotic pressure, है ना? What it depends on, है ना? How should the apparatus and all be, है ना? Now let us look at the qualitative analysis. Okay, in qualitative analysis we will derive the formulas and all. Now we can also write directly. First of all, osmotic pressure. अच्छा देखिए, basically what is osmotic pressure? We have two compartments like this. Okay, there is a pipe like this, there is a semi-permeable membrane. Okay, and let us say that here you have a 0.1 molar NaCl solution, and here you have 0.2 molar NaCl aqueous. ठीक है, अब ये बताइए which of the option is correct. Solvent will flow. Solvent will flow A to B, B to A. And tell me.
Sir, first two.
Yes, what about others? Hanifa and Rifat. Look at the definition of osmosis. What is osmosis? And then tell me. Yes, Rifat, tell me. Hanifa, you can send the answer in chat.
B to A.
Correct. What about Rifat? What do you think?
B to A.
B to A, na? Okay. Acha, Hanifa did not think. Hanifa was speaking. Okay, fine. Zad, why did you say A to B?
Sorry.
So, huh?
I made my mistake.
Why it will go from B to A? Tell me, Zad, then.
So it is in B. It is low concentration. So it goes from low concentration to high concentration.
Low concentration of what? Solute or solvent?
Solute.
Solute. Very good. And please remember, it will flow from lower concentration of solute to higher concentration of solute. Okay, lower concentration of solute to higher concentration. Okay. And what is deriving this flow? We all know that what is deriving the flow? The vapor pressure here is more. Right? The vapor pressure is here more. Okay. So the vapor pressure is more here. That is why what is happening? More and more solvent is going this way. Achha, if I add some external pressure here, and if I add some external pressure here, just to stop the flow, what I'm doing, I'm adding a external pressure just to stop the flow. Okay, just to stop the flow. Okay, now you will tell me, here I will apply the pressure P1. Okay, we have another case. Here we have another case. Everything is same. Here we have 0.1. Okay, here we have 0.1, and at this point we have 0.3. Okay, 0.3 molar. There is a similar case, one more. Here we have 0.1. Here we have 0.4. Okay. In the first case also, we are applying pressure P1. That is just stopping the flow of solvent from B to A. From B, this is B and this is A. Okay, from B to A. So everywhere it will go from B to A, B to A, B to A. Here it is P1, here it is P2, and here it is P3. And all of this P1, P2, and P3 are the respective osmotic pressure for each and every solution. For the individual solution, these are the osmotic pressure. Now you have to tell me what will be the order of P1, P2, and P3. Send in the answer in chat, okay? Send the answer in chat. What do you think will be the order of pressure 1, 2, and 3? Where will I have to give more and more pressure in order to stop the osmosis? No idea? Achha, let me change this one to. The D option is no idea. Okay, Hanifa and Zad are giving different answers. Achha, Hanifa, can you explain your answer? Aha, your mic is not working. How will you explain? Huh? Rifat, can you explain the answer? Achha, nahi, Rifat ne to answer hi nahi diya. Rifat?
Yes.
What do you think? What will be the answer? Achha, did you send the answer?
No.
Achha, if you will send, send it to Salim, okay? Not to Learnivio. Okay?
Okay.
I have access to Salim. अच्छा, फर्स्ट ऐसे सोचिए आप लोग, ऑल ऑफ यू प्लीज थिंक इन दिस वे. वी आर ऑल कंसर्न विद द ए, है ना, बिकॉज ए इज डिफरेंट, जो डिफरेंट होता है उसी को देखते हैं, है ना. So here in all the three cases we see that B is same, 0.1, 0.1, 0.1. Whatever difference will be there in P1, P2 and P3 will be only due to A. Correct? Yes or no? Please tell me.
Yes.
Right? Now what we will see, what is the difference in A, B and C? First of all, tell me what is the difference in the three. Let's say that this is first solution. First, second, third में क्या difference है? What is different in the A compartment? Their concentration, right? Yes or no?
Yes.
Their concentration is different. Achha, what is happening to the concentration? It is increasing, na? 1, 2, 3 se. Yes or no? It's
Yes.
increasing, right? Okay. Achha, if we will have, this is pure solvent, water. This is 0.1 molar. This is 0.2 molar. Okay, this is 0.2 molar. Now, water will have the greatest vapor pressure. Yes or no? Please tell me.
Yes.
Right? Then it will be followed by 0.1 molar. It will have slightly less than water. Correct? Yes or no?
Yeah.
Rifat, Hanifa, Zaid, all of you understood? And we can say that
Yes.
0.2 molar, 0.2 molar will have the least vapor pressure because there will be plenty of molecules of solute which will be occupying the spaces in surface and they will be hindering the vaporization, and that is, if vaporization is not happening, no vapor pressure will be there. Now you tell me where we will be having least vapor pressure in 1, 2 or 3. Least vapor pressure will be where? Which
So
of the 1 में तो 0.2 molar है. Here we have 0.3, and here we have 0.4. Right? Direct is, I'm asking about vapor pressure. Vapor pressure is directly proportional to concentration. Yes or no?
yes.
Sorry. Vapor pressure of, vapor pressure is inversely proportional to concentration. If the concentration is higher, as we saw, water was 0. 0.1 had lower vapor pressure.
So
0.2 had.
then third one.
है ना? Third one, right? Rifat,
Yeah.
got this?
Yes.
हाँ.
It's the third.
Third one. अब solution का जो अपना vapor pressure है, that is very low. Correct? Right?
Yes.
Now, in order to make it equal to the B compartment, we have to add what? We have to add large magnitude of pressure. Is that right? Yes or no? Please tell me.
Yes.
Yeah. What we have to do? We have to add pressure in order to stop the flow. Here, this, if I talk about this B1, this B, this B, and this B, all of these B are having same vapor pressure. But in order to make the vapor pressure of A and B equal, what we have to do? We have to give large amount of pressure in the third solution, then in the second solution. And that is why, which option will be correct? The P1 is smallest, then P2, then P3. And in P3, that means in the third solution, I have to get the most magnitude or the largest magnitude of pressure in order to stop the flow of solvent. Is that right? Yes or no? Please tell me.
Yes.
Rifat, Hanifa, got this point?
Yes, sir.
आ गया ना? Rifat, okay, fine. That means what I will write? The osmotic pressure pi is directly proportional to the concentration. Is directly proportional to the concentration, and the concentration term which was found to be directly proportional was molarity. Is found to be molarity. Now what we will do? Pi, it is equal to pi. It is equal to some constant k times molarity, right? Times molarity. Acha. Also, you should understand one more thing. That molarity, if whenever this molarity type of thing will come, you will see. Acha. You will remember one formula from 11th standard, that is PV is equal to nRT. Right? Yes or no?
Yes.
Please tell me. Hai? This is for gases, correct?
Yes.
This is for gases. Hai? Achha. And the pressure that we are talking about, that is also due to vapor pressures, yes or no? Correct?
Yes.
That is also due to the vapor molecules. The vapor molecules. So similarly here, this pressure is what? This pressure is the vapor, this osmotic pressure only. Hai? Now what I will do, I will just write and rearrange this thing. You see here, P is equal to N upon V into RT. This pressure is what? This is pi. N upon V number of moles, upon volume in liters will give you molarity, right?
Yes.
Into R into T. And this is written as P is equal to CRT. Will all of you remember this? Yes or no? Please tell me. Rifat, Hanifa, and Zain.
Yes.
Yes.
Okay, fine. Here we can write also CRT. Na? Pi is equal to number of moles of solute divided by volume in liter into R into T. Okay, NB is what? Moles of solute, and volume is volume of solution in liters. See here, ab iske baad you can do some more arrangements. Okay, I'm not a very big fan that you have to write NB is equal to what? Given mass upon molar mass of B. So you can arrange this here also. You can write it WB upon MB into volume into RT. Now this is also what? This is also pi here. Okay. Now this formula can be used directly in order to calculate the molar mass of, solute. So what we can write? MB is equal to WB upon pi into V into RT. है ना? Then all of you, so please tell me.
Yes.
Yes, sir.
Fine. I'll write a note here. Osmotic pressure is used to determine the molar masses of macromolecules like polymers and proteins. Okay, this question was asked for 2 marks. Okay, simple hai na? It was asked what which method is used to calculate the molar mass of macromolecules like polymers and proteins. This was asked for 2 marks. Okay, in 2015 CBSE. Please write this down. Let me know when you're done. Raise your hand if you're done. Okay. Zayad is done waiting for Hanifa and Rifat. Rifat, am I pronouncing your name correctly?
Yes, sir.
Okay. Where are you originally from?
Karnataka,
Where in Karnataka?
Bangalore.
Bangalore. Okay, Hanifa is done. Just waiting for Rifat now. All of you done. So you can write a question now. Okay. So write the question with me. Right. A solution prepared by dissolving. A solution prepared by dissolving. A solution prepared by dissolving 8.95 milligrams of gene fragment of a gene fragment in 35 ml of, let us say, of water. A solution prepared by dissolving 8.95 mg of a gene fragment in 35 ml of water has an osmotic pressure of 0.335 torrs at 25 degree Celsius. Is right, assuming में double में आता है, क्या आता है? Seems right. Assuming the gene fragment is non-electrolyte determine its molar mass. Okay, so we try this question. You've just seen the formula, right? Directly you can calculate. Keep in mind, please keep in mind the units. Okay, please keep in mind the units. Here it is milligram. You have to convert this to gram. Here you have ml, which you have to convert to milli. So you have to convert this to liter. 25 degrees Celsius. You have to convert to Kelvin scale. Okay. The importance of this question has been asked in 2011. For how many marks? Simple question, 3 marks. Formula based, simple question, 3 marks.
So R value we have to take 0.0821.
R का वैल्यू तो आपको नहीं बताएगा ना कोई है. What you should take? Tell me.
So it is liter atmosphere. So I think 0.0821.
Okay. Where did you find one ATM? You have, I mean, you have to convert this to ATM and then only you can use that. No?
Yes,
Here it
yes.
is TOR. Here you have TOR. Okay. If you convert this to ATM, then you can use it.
So we can just divide it by 760.
Correct. So let us do the conversions first. Now, so the given mass of solute WB is equal to how much? 8.95 milligrams. This will be equal to 8.95 into 10 to the power minus 3 grams. Right. The volume is given to be 35 ml. We have to take this in liters, and this will be equal to 35 into 10 to the power minus 3 liters. Right. After that, osmotic pressure pi, it is given as 0.335 torr, which you have to convert to ATM. It will be 0.335 divided by 760. Divided by 760, and this will give you ATM. Okay. Now what else is there? Temperature is also there. No? So temperature you have to convert. So temperature is 25 degrees Celsius. You just need to add 273.15 plus 25, which will give you in Kelvin how much? 298.5, no?
Yes.
298.15 Kelvin. Okay. You have to use this formula. What formula you are going to use? You are going to use the formula that we just wrote. Actually, in CBSE, you have to write all of these things. Like you have to start from this. Pi is equal to CRT, then only you will get marks. Okay, pi is equal to CRT. Then what you will do? Write pi is equal to number of moles of solute divided by volume into R into T. This will be equal to the given mass of solute divided by the molar mass of solute into the volume into R into T. And then you will write MB is equal to how much? MB, it is equal to what? MB will be equal to WB into RT upon pi into volume. है ना? Please plug in the values, calculate and send the answer in chat.
So the calculation is little long.
हाँ, that is why it is of 3 marks. Otherwise, यहाँ तक तो it's nothing ना. These questions like you don't get marks here for formula, and you get marks for spending time on it. But there are some things that you can do ना. There are some things that you can do. हम बता रहे हैं आपको. 8.95 है. Approximate this to 9. Okay, fine. Then you have 0.0821, correct? Okay.
Yes.
What do you do? यहाँ पे आपने क्या किया? Here you have increased, right? 8.95 से you have increased to 9. What here you do? The approximation here you will do is 0.08. आपने क्या किया? थोड़ा घटा दिया, है ना?
Okay.
Both the things are there in numerators only, right? Both the things are there in numerator, right?
Yes.
है ना? And then you have 298.15. इसको क्या कीजिए आप? इसको भी थोड़ा घटा दीजिए, 298 कर लीजिए. Okay. Then try. I can write this as approximately equal to 9 into 10 to the power minus 3 into. Then we have R, that is 0. We will write 0.08 into. Then we have 298 Kelvin, right? Then divided by this is 0.335 divided by 760 into volume is how much? 35 into 10 to the power minus 3. So we can eliminate these two, na? 10 to the power minus 3 from here, 10 to the power here. Okay. Now you have to calculate. 9 into 0.08 into 298 into 760 divided by 0.335 into 35. Let us get rid of the decimals, hai na? So what I will do, I will increase 1 point from here, 1 point here, 3 points here, and 3 points from below. So we'll get 9 into 80 into 298 into 760 divided by 335 into 35. Chaliye. Now I think it will be okay for you guys. Okay, I got an answer. Let's see. So around you're getting okay. It's fine. It's okay, Zed. Yes, Anifa, approximately it is correct. Those who are done, please try to do this question. One centimeter cube is equal to 1 ml. This is basically a very simple question. Please try this. Done.
So it's coming 0.2.
नहीं नहीं आगे तो कीजिए.
हाँ.
0.2 ही आ रहा है क्या? Send the answer in chat, okay, when you're done. रिफत, आपका पिछले वाले का आंसर नहीं आया? Yes, रिफत.
I didn't divide it.
Why? You will not
Yes.
get marks if you don't divide them, okay?
Yeah.
Please remember this. कुछ तो गड़बड़ी कर रहे हैं आप. Little mistake there. Okay.
Sir,
Hmm.
we take it in milliliters or liters?
Liters. वॉल्यूम शुड बी इन लीटर्स है ना. हम ये बता रहे थे मतलब 1 सेंटीमीटर क्यूब इक्वल टू 1 ml एंड इसके बाद तो फिर आप कैलकुलेट कर लीजिए ना व्हाट विल बी 1 लीटर. ओके, कन्वर्ट फ्रॉम ml. So 5 will be equal to what? WB is 1.71 gram of that which we have taken into 0.083 times temperature is 300 divided by molar mass 342 into the volume, no? 0.5 liters. So into 171 into 0.083 into 3 divided by 342. Rather than writing 0.5, I will do into 2 here. 6 आ रहा है. I think it is fine. Zad, Zad, yours is fine. Okay, sorry, yours is fine. मैंने उसको गलत read कर लिया था. I read it something else. I read it 2.8 by the way. Na? So this will come around 0.25. Okay, what will be the unit? Tell me. Pressure unit क्या होगा?
So ATM.
अरे भाई ATM यहाँ बार है तो
sorry.
ATM होगा. हाँ, यहाँ ये
हाँ,
बार
बार.
है ना. इतना हड़बड़ी क्यों है आपको? बार है यहाँ पे तो. Everyone done? Yes or no? Hanifa, Rifat?
Yes.
Yes. Okay, fine. See, molar mass is calculated. And we have just written this point now. That osmotic pressure is used to determine the molar mass of macromolecules like polymers and proteins, etc. Right? So one thing you should also know is what are the necessary conditions. Okay. Right? Necessary condition. For determination of molar mass using osmotic pressure. है ना? Pi मतलब osmotic pressure. The first thing should be तो आपका solute होना चाहिए ना. The solute should be non-volatile. That means solid. Solute must be non-volatile. Second point, the solution must be dilute. Must be dilute. Okay, but the concentration should be less than or rather less than 5%. I think less than 5%. Okay, W by W. Third is the solute should not undergo any association or dissociation. So if these three criteria are met, then the determination of molar mass will be quite accurate. Okay, please write these 3 points. Let me know when you're done. Done all of you, yes or no?
So did.
Done na? Okay, fine. Next is biological importance of osmosis. So there are two questions which are important in this part. First is, let us say what will happen if body cell comes in contact with water or some water or some dilute solution whose osmotic pressure is what? Whose osmotic pressure is less than that of body cell. एक काम करते हैं, ऐसे लिखते हैं इसको, A पार्ट कर लीजिए. A part less than that of body cell, B part more than that of body cell. ठीक है? Now listen. Here this is a cell, this is of body. Okay, and there is a new cell here. Okay, and what they are saying, whose osmotic pressure, na? Please remember whose osmotic pressure is, na? Whose osmotic pressure is what? Whose osmotic pressure is less than that of body cell, है ना? You got it right. Pi is less, na? Whose osmotic pressure is less than that of body cell. Then what will happen? Tell me. Here you have, here the pi is more, here the osmotic pressure is more. If the pressure is more, what will happen? The solvent will flow from body to the, guest molecule. Yes or no? Correct?
Yes.
Right? What about others? Hanifa and Rifat, tell me. What will happen? Listen. I have to make compartments only, I think, Anna. Then only you guys will speak. And this is body. Okay. And this is what? This is, let us say, host or guest. Sorry. Okay, it is guest. Now, what they are saying, here the pi body is more, and here the pi is less. Okay. अब ये बताइए, here you have guest and here you have body. Concentration is higher in A guest molecule or B body? Tell me. Concentration किसमें ज्यादा होगी? Concentration of solute is higher where? Guest में या body में?
Body.
Will be higher in the body. ठीक है? So concentration is higher here and concentration is lower here. Okay. Now you tell me, where will the solvent flow from? It will go from guest to body or body to guest?
Guest to body.
है ना? That's on my बात?
Yes, sir.
Okay. It will go from guest to body. This is how the flow of solvent will be there. Now, what will happen if the water molecules get into the body cell? The body cell will expand or it will swell or it will shrink. then what will happen? Body cell will क्या होगा? फूल जाएगा या फिर shrink कर जाएगा?
So it will gain size, so it will
है ना? Swell ना, body cell will swell. Now in this case what will happen? Body cell will shrink. Body cell will shrink. Okay, and when it swells, the technical term for this is what? It is hemolysis. Okay, erase these parts. Just a second. Technical word for this is plasmolysis. Done all of you, yes or no? Please tell me.
Yes.
Okay. No, right. Write the heading isotonic solution. Okay, so what are isotonic solution? Very simple. The solutions which have same osmotic pressure at same temperature are called as isotonic solutions. Okay, please write with me. The solutions with same osmotic pressure at same temperature is called, or sorry, are called, लिख लीजिए ना, solutions लिखा है ना, are called isotonic solutions. Are called isotonic solutions. There is a similar word, hypertonic solution. Hypertonic solution. Hypertonic solution will be solution with higher osmotic pressure than some other solution. Then there is another word, hypotonic. No. Definition is solution with lower osmotic pressure than some other solution. आप लोग में से किसी का पानी चढ़ा है? जैद, रिफत एंड हनीफा?
So like what?
हॉस्पिटल में बीमार पड़ जाता है तो पानी चढ़ता है ना। हाँ हाँ, यस हनीफा।
The IV drip.
आई ड्रॉप,
IV.
कैन यू प्लीज टाइप
So you mean
राइटिंग?
glucose, मतलब dripping, by dripping?
हाँ
Yeah.
हाँ
Okay.
हाँ, ड्रिप ड्रिप चढ़ना, हाँ हाँ करेक्ट, ड्रिप।
I think once when I was small, maybe.
When you were small. What about you, Hanifa and Rifat?
No, sir.
No? अच्छा,
No.
good. But देखा आप लोगों ने, right? You must have
Yes.
seen or you must have heard, right? क्या बोलते
Yes.
हैं, क्या चढ़ रहा है? सलाइन चढ़ रहा है उसको,
Yeah, saline.
सलाइन चढ़ रहा है ना? So what is saline? What do you think? Saline will be containing salt, right?
Salt.
Containing salt, okay. Now why don't they just give you water? Why salt? No, water will be easier.
So salt will have electrolytes
Electrolytes नहीं नहीं, NaCl होता है इसमें बस,
and
इलेक्ट्रोलाइट नहीं होता, हाँ बस NaCl होता है, no other essential electrolytes. Yes, Rifat, Hanifa, any idea why saline, why water containing salt, not normal water? See, and this saline, this saline water, it has a very particular concentration. It has a very particular concentration. Its concentration, the water that is given, its concentration should be 0.91 percentage mass by volume. Okay, that means if you have 100 ml of water, sorry, if you have 100 ml of, let us say, solution, or let us say 100 ml of solution, then in this solution there should be 0.91 grams of NaCl. Okay, is that clear?
yes.
Okay, why is that? Why is that? This is why is that 0.91 percentage mass by volume of NaCl is isotonic with red blood cells. ठीक है, NaCl वजह से वो नस में जाता है ना, so it is coming into contact of red blood cell, like तुरंत it is coming into contact with red blood cells, right? Whenever you are getting drip and saline water, it's coming into contact with RBCs, and this concentration it is isotonic with RBC. That means both of their osmotic pressures are equal. Osmotic pressure of saline with 0.91 m by V, and osmotic pressure of RBCs. ठीक है, osmotic pressure of RBCs both are same. इसीलिए what do? We add the saline water which is having 0.91 percentage NaCl. Is that clear? Yes or no? Please tell me.
Yes, okay.
Okay, and also that is why what happens now, whatever medicines that you are taking, they are also inserted, like they're also given to you, like in injections and all. Now you have saline water only in them because it is liquidy, right? It is completely liquid. That is also having saline water in that. Is that clear? Yes or no? Please tell me.
Yes.
Okay, now question. What will happen? What will happen? What will happen if solution with less than 0.91 percentage m by V of NaCl is injected into body? ठीक है, क्या होगा? ठीक है, here you have saline water, here you have red blood cell. Okay, now if the concentration, तो lower concentration कहाँ पे है? The concentration is lower here, less than, and here the concentration is higher. अब बताइए ब्लड का, सॉरी, पानी का फ्लो कहाँ से कहाँ होगा?
So S2R.
ऐसे होगा, है ना? Yes, yes, na. What will
Yes,
happen to
yes.
the red blood
Yes,
cell
sir.
then? है ना? The red blood cell will swell. ठीक है? Okay.
Okay.
Is that clear? Acha, what will happen if the concentration is lower, right? The concentration is lower here, right? And the concentration is higher here. Now, if the concentration of this is lower, that means it is hypotonic, right? It is hypotonic. And if the concentration will be more, then it will be what? It will be hypertonic. Okay. Now, similar question that you can write here is, what will happen if solution with less than more than 0.91% m by v of NaCl is injected into body. Answer will be RBC will shrink. RBC will shrink. Is that clear? Yes or no, please tell me.
Yes.
Okay. Now, all of you drink water from RO. Yes or no? RO?
Yes, sir. Reverse
RO.
osmosis.
Reverse osmosis. What happens in reverse osmosis? See, the concept is very, very, very easy to understand. Okay. Here we have pure water. Here we have impure water. बताइए concentration कहाँ ज़्यादा होगी, A में या B में? Where will be the concentration higher? Concentration high कहाँ पे होगी? A or B? अरे this is pure water. Impure water, right? In A, correct? In A the अरे yes or no, Rifat, Hanifa? Yes, Rifat?
Yes, sir.
Yes.
Yes, na, impure water will have higher concentration. Concentration is higher here and concentration is lower here. Now you tell me where the water will flow from B to A, correct?
Yes.
सही है? Okay. अब इसमें क्या करते हैं? We will apply some pressure. External pressure we will apply, and that pressure should be just above osmotic pressure, है ना? Should be just above osmotic pressure, and what will happen? The reverse osmosis will start to happen. Now here the pressure is more. If the pressure is here more, then what will happen? The impure water से क्या होगा? Solvent. That means water will start flowing from A to B. Is that clear? Yes or no?
Yes.
है ना? देखिए, if I talk about spontaneity, then what should happen? Here you have more pressure. Here you have more pressure initially. So this is B, this is A, this is pure. Naturally, what happens? B to A. But if I apply more pressure here, then what will happen? The direction of osmosis will get reversed, and that is why it is known as reverse osmosis. Okay, that is why it is known as reverse osmosis. So what will write here? Write the definition with me of reverse osmosis: the process of movement of solvent through semi-permeable membrane, SPM, semi-permeable membrane. Now from this solution of higher concentration to from the What? From the solution
Lower
of
concentration.
higher concentration to lower concentration. Solution of higher concentration. Okay, that means impure to lower concentration. That is pure. Is called reverse osmosis. Is that clear? Yes or no? Please tell me.
Yes, sir. Clear.
Yes, sir.
Please let me know if you're done writing.
So finish.
Okay, all of you done? Both of you? Hanifa and Rafal?
Done.
Done? Okay, fine. Now, I think there are a few things that I have to write. I have to write about antifreeze and all. We did not study now after depression in freezing point. Okay, just
No,
let
sir.
us write a let us write a few points about antifreeze. So questions aa jate kai baar, है ना? Then we can. Antifreeze solutions. Okay, so this is related to depression and freezing point. Okay, depression and freezing point. As you know, what happens if I add some solute? If I add some solute, what will happen? The freezing point of a solution that will decrease. There will be a decrease in the freezing point of the solution. Okay, so what happens? Like not here. Okay, not in India, but I hope all of you know that in most of the Western countries during winters there is snowfall. Right? Yes or no?
Yes.
है ना?
Yes.
अच्छा, and all of you must also know that there are batteries inside. There are batteries inside vehicles, correct?
Yeah.
अच्छा, आप लोगों के घर में इन्वर्टर है? किसी के पास? You have inverter? No.
When I was in India, I had it.
है ना? अच्छा, those who have inverter, they will know that you have to add distilled water inside the battery
Yes.
to keep it working, है ना? So similarly, sometimes you will also see in movies and all कि bonnet खोला उन्होंने, है ना? कार का उसमें पानी डाल रहे हैं, है ना? So those things are there to keep the battery healthy. Now, what will happen if there is winter and there is the temperature is 0 degrees Celsius and -degree Celsius? Okay, then what will happen at that time? All the water that is present, it will convert into what? It will convert into ice, and nothing will work at that point. Nothing will work at that point. So in those cases, what happens? Antifreeze solutions are added to them. What they do, they decrease the freezing point of water to lesser degree Celsius. For example, let us say that freezing point of water is 0 degrees Celsius. They will decrease and they will lower the freezing point to -10 degrees Celsius. So till -10 degrees Celsius, you will be having water, that you will be having liquid, and after -10 degrees Celsius, it will start to freeze. Okay, so these are antifreeze solutions. In India, there is not much application, but in general, we can see these things, they have some application. Okay, so please write. You should write it like this, to avoid freezing of water, avoid freezing of water at places where temperature goes below 0 degrees Celsius, below 0 degrees Celsius. What should I write? Goes below, to avoid freezing of water at places where the temperature goes below 0 degrees Celsius. Some solute, generally it is ethylene glycol. Generally, ethylene glycol is added Avoid freezing of water. Some solute, generally ethylene glucose is added. Sorry, glycol is added. These solutions are called antifreeze solutions. Okay. Now, another, you can say, application of depression in freezing point is clearing of snow from road. So again, when you have snowfall, there will be snow in the road, and how to clear them easily. What happens? On the snow, you will add common salt, that is NaCl or calcium chloride, whatever is cheaper. You will add some solute, है ना? And then what will happen? Slowly, it will get dissolved into ice. And now what will happen? The freezing point of ice will be lowered. So now it will become, if you add salt into any ice, now it will become water because the freezing point has been lowered. So you can write addition of common salt to snow lowers the freezing point of water to such an extent that water cannot form ice, no? And hence snow on the road melts easily. Right, one more question. What will be the effect of increasing temperature on osmosis? So osmosis will slow down or it will be faster. That means the movement of solvent from a solution of higher concentration to lower concentration, will it increase or decrease or remain same?
So
Answer in
it
the
will
chat,
increase.
answer in chat. Answer in chat, then I will ask the reason why. Answer in chat, what will happen to osmosis? The rate of osmosis will increase, decrease, or remain same. Waiting for Hanifa and Rafat. Send the answer in chat. Yes, Hanifa? No idea? Rifat, what about you? I can't hear you, Hanifa. Can you please type if you are speaking? Yes, Rifat, आप बताइए. What will happen to the osmosis? What will happen to osmosis if we increase the temperature? Correct, Hanifa. Rifat, are you? हाँ, Rifat, आप बताइए. हाँ. What happened?
Sorry, I could not hear you for a moment.
Okay. Now can you hear me?
Yes.
बताइए.
The effect. The water molecule.
No, I am asking how the osmosis will be affected. That means, will it be faster? It will be slower, or it will remain same? The rate of osmosis.
Increasing the temperature means it will be fast.
It will be faster, right? Very good.
Yes.
You all know pi. It is directly proportional to temperature. Now, see, pi is equal to CRT, है ना? So it is directly proportional to concentration as well as temperature, right? And that is why what will happen. What should I write here? The process is accelerated by increase in temperature. Chalo. Achha, there is one announcement for all of you guys. Tomorrow, that is Sunday, you will have a Viva. The topics that I will be asking is, I will be asking till elevation in boiling point. Is that clear? Yes or no? Please tell me. Elevation in boiling point.
Okay.
Okay. Fine. Achha. Hanifa, can you please speak?
Yes, sir. Can-
हाँ, अब बताइए, अब क्या बोल रहे थे क्लास के स्टार्टिंग में? आपको कुछ डाउट्स हैं?
Yes, sir. I have few questions.
You have doubts in 4 questions. Am I hearing this correctly?
Yes, sir.
Okay, fine. Zad, what about you? आपने तो NCERT try ही नहीं किया. You don't have any doubts.
So I have done.
Sorry?
NCERT हमने पूरा कर दिया है क्लास.
You have done, then you have to show me that only.
Yes.
Don't redo it. Okay, if you have done, then just send me the photos. That's it.
Okay.
Okay, fine. Okay, Hanifa, okay, fine. Rifat, do you also have some doubts? आपने भी स्कूल में क्या होगा तो?
Not now.
Not now. आपने हाँ ठीक है ध्यान नहीं होगा. Okay, fine. So Rifat, आप ये बताइए, when are you free? When can we have a lecture? Backup कब मिलेगा आपको बताइए? See, the time that you can, हम बता रहे हैं आपको. Wait a second. Monday, Wednesday. It should be after 6:30 वहाँ होगा तो यहाँ पे it will be 9 o'clock ना. 9 o'clock 10 7:30 हाँ. So from 7:30 you have on Monday and Wednesday. Okay, you can have an extra class on Monday or Wednesday after 7:30. Okay, and then you can have on Friday. So today your class was from 4 p.m. right?
Yes.
है ना? So we can do either on Friday 4 p.m. बताइए अब इनमें से कौन सा टाइम ठीक है?
Friday.
Friday 4 p.m. is fine for you?
Yes.
KSA टाइम है ना?
Yes.
ठीक है, यानी कि इंडिया में इट विल बी 6:30. तो नेक्स्ट फ्राइडे आप ये करेंगे, ठीक है? लेकिन आपको समझ में आ रहा है अभी, है ना?
हाँ.
है ना? ओके फाइन. अब ट्राई कीजिए, देखिए सॉल्यूशन चैप्टर, इलेक्ट्रोकेमिस्ट्री चैप्टर, इन दीस चैप्टर्स व्हाट यू विल बी देयर, यू विल बी गिवन प्रॉब्लम्स, है ना? यू विल बी गिवन न्यूमेरिकल्स, उसको सॉल्व करना पड़ेगा. अच्छा, Now, what a pattern that I'm seeing here in Middle East is that all, like, each and every school has taught solution, and the next chapter that they went to is haloalkane and haloarine. है ना? Please raise your hand if this is correct with your school. कि haloalkane haloarine तो हो रहा है. अच्छा, not in Hanifa's school. Hanifa आपकी स्कूल में क्या हो रहा है? Can you please write in Hanifa की भी स्कूल है ना? So what I will do, I will also follow the same thing. ठीक है? After solution, ठीक है? Is that fine? Yes or no? Please tell me.
Yes.
है ना?
Yes,
अच्छा,
sir.
basically, and for your NEET, if you are preparing for NEET or JEE, then Mohit Sayal sir will take you classes. Mohit Sayal sir will take classes basically only for NEET and JEE. Okay, so he will be focusing on those portions, like the type of questions which are asked in NEET and which are asked in JEE. So we have segregated these things, and that is why I will be giving you previous year questions from CBSE and all. Some parts and portion will be there that you will find it useful in NEET and JEE also, obviously, because everything is from NCERT only. But Mohit Sayal sir will be focusing solely on NEET and JEE portions, the type of questions which come in NEET and JEE, and how to study for NEET and JEE. Each and everything you can ask from Mohit sir. Okay. Now, what we will be doing, we will be trying to focus and we will be trying to keep you in track with your school also. Will that be fine? Yes or no? Please tell me.
Yes.
है ना?
Yes.
चलिए, ठीक है. Okay. Fine. So tomorrow we'll learn about abnormal molar masses, and then we will do some previous year questions of some miscellaneous topics, है ना? जैसे वो NCERT के टेक्स्ट से एक वर्ड से सवाल देते हैं. So those questions we will do, and then we will be completing this chapter. And hopefully we'll start with haloalkane and haloarine. I will discuss this with with someone. Then we will start with haloalkane, haloarine. Most probably haloalkane, haloarine will be our next chapter. Okay. चलिए, fine. Thank you very much, guys. Take care, all of you. And कल वाइवा के लिए प्रिपेयर करके आइएगा. Okay.
Thank you so much.
Thank you,
Okay.
sir.
हनीफा आप रुकिएगा. हनीफा आप रुकिएगा. हाँ हनीफा, आप बताइए. आपको 4 सवाल में डाउट थे. हम 1 सेकंड खोल लेते हैं. You have time ना? आपको कहीं होना तो नहीं है? हाँ
No, sir.
तो ना. Let us see this question, है ना? चलिए, ये नहीं हुआ था आपसे? नो. ओके. बताइए. आई एम नॉट शेयरिंग माय स्क्रीन. सॉरी.
Yes.
हाँ. या. कैन यू सी द स्क्रीन नाउ?
Yes, sir.
ठीक है. अच्छा, आप कंसंट्रेशन टर्म्स वाली क्लास की है आपने कि नहीं किया है?
No, sir. I didn't, but I can. Sir.
अच्छा, तो फिर आपने लेक्चर की रिकॉर्डिंग भी नहीं देखी है?
I didn't get it.
You didn't?
No, sir.
Fine. First thing is that we will translate this. Okay. A solution of glucose in water as 10% W by W. ठीक है. This is the first thing that we'll do. उसके बाद आपको आ जाएगा. What will write? 10 gram of glucose in 100 gram of solution. अब ये बताइए हनीफा, if you have 10 gram of glucose, so you can also write 10 gram of glucose in dash gram of water. बताइए, what will be, how many grams of water will be there? Sorry, can you please write in chat?
9.
90 है ना? 90 right? 90 ना?
Yes, sir.
90 ग्राम.
Yes.
अरे बहुत ही ज्यादा खराब आ रही, पता नहीं क्यों आपकी आवाज, है ना? Okay. Is my voice clear, हनीफा?
Yes, sir.
ठीक है.
Actually,
what
my
would
mic broke my
your
mic
mic?
broke the other day. So it
Okay.
it
So
broke.
what you're
So
using? You're using a mobile phone.
no, like I fixed it, but it's like it's not compatible. So I'll have to get a new one.
So no, you can just remove the earphone, na?
No, but so the audio wouldn't be clear.
Okay, fine. Then what they have asked, what would be the molality and mole fraction of each component in the solution? Do you know the formula for molality?
Yes.
Molality is equal to, tell me.
Moles of solute by mass of
Sorry.
solution. Moles of solute by mass of solution grams into
Okay. Moles of solute by
mass of
mass of
solution.
solvent. Mass of solvent. Okay, in kg. Okay. Achha.
Yes, sir.
Can you get the number of moles of solute from here? Yes or no? Tell me that.
Yes, sir.
In B, it will be equal to the given mass upon the molar mass. Given mass is 10. Molar mass of glucose is 180 grams per mole. Okay. Grams per mole. This will be grams. Grams and grams will cancel each other, and you will get this as 1/18 moles. Okay. Is that clear? Yes or no? Please tell me, Hanifa.
Yes, sir.
And from here, you can get the mass of solvent, which will be equal to how much in kg? It is 90 grams. So it will be equal to 90 upon 1000 and it will convert into kg. है ना? तो ये क्या आ जाएगा? 0.09 kg. Clear है? Yes or no? Please tell me.
Yes, sir.
And I just need to write down 1/18 into 0.09. तो ऐसे लिख लेते हैं, यहाँ पे 90 लिख लेते हैं, and this will become 1000, है ना? And then you will find out the molality. Easy. Yes or no? Tell me.
Yes, sir.
है ना? ठीक है. One thing that you will try to do is you will just wait a second. Let me send you the link on you. Okay. आप इसको एक बार देख लीजिए. If you have not done, we will do one concentration term class with you. But for the time being, na, can you please watch a lecture for the time being? Huh?
Yes, sir.
है ना? Then we will Learnivio.